In example 2, we want to use a graphing calculator to solve or graph the following systems, then write the solution down. So let's take a look at the first one, A. In A we have 3x plus 1 and also 3x plus 5. So we're going to hit our y equals button. We can cursor 1 to the right here, and we've got our first equation we can type in. So I'm going to type in a 3, and x, you can just type this key right there. And then we've got a plus 1. The next one is going to be 3x plus 5. What we can do now is just hit zoom and then either cursor down or just hit number 6, and it'll go to the standard viewing window. So you can see here that these two lines are actually parallel. There is no solution to this system. So what we're going to do is we're going to write no solution down here on the bottom. I think that's going to be just at the bottom here of the page. I'll scoot that up just a little bit. If we're going to graph these, 3x plus 1 would have a y-intercept at 1 and then a slope of 3. So it's going to look a little bit like this. And you could pull those points off of the graph on the calculator as well, but it's easy enough to graph these by hand, I think. So there's the first line, and the second line is 3x plus 5. So same slope, different y-intercept. And you can tell here, now that we're drawing these two, that they definitely are parallel and therefore will never intersect, and there is no solution to that system. With the next one we have a line and then something that's a little bit different. Let's see if we can figure out what that looks like. So I'm going to clear out each one of these by just cursoring over them and hitting the clear button. And then I'm going to go to y sub 1. I'm going to type in negative 5 over 2. You have to use the negative key, so the negative key is this one right here. And it's going to be negative 5 divided by 2, and then an x, and then I think we're at plus 5. The next one is y is equal to x squared minus 4, so I'm going to type in x. Now there's two ways you could do this. You could either type this little key here, which is the x squared key, or you can type this button here and then put a 2. But I'm just going to type this that little x squared key, and you can see that it just raises that variable to the second power. Then we'll subtract 4. So we can just hit graph, or you can go back to zoom 6. Either way. Let's see what this looks like. So there's our line, and now we don't have a line. So this one actually looks a little more interesting, and I think we're going to graph this quickly here. It looks like there's 2 and negative 2 are the x-intercepts, and then negative 4 would be the y-intercept for that parabola. So we're going to graph it pretty closely, just kind of like this. That's going to continue up here. This side's going to keep going. There we are. And then the line has a y-intercept of 5, a slope of negative 5 over 2. So that's going to be down 1, 2, 3, 4, 5, and right 2. 2, 3, 4, 5, right 2, and so on and so forth. So try to get this ruler out here. So let's graph that up. There we are. Now, even though it doesn't show it, we know at some point over here somewhere, maybe negative 3 something, somewhere in there, these two will intersect again. So here there's actually 2 points of intersection. We know this one is right here at 2, 0. Let me show you how you can use the calculator to find that. So what we do is we go to second, and then we hit the trace button. And that's going to get us to this calculate menu. We're going to go down to number 5, where you can just hit 5 and then hit enter. The calculator wants to know the first curve. It lists y sub 1 here, and it's on the line, so we're going to hit enter. The second curve, the cursor automatically jumps to the next one, and that's the next one we want. It also lists y sub 2 up here, so we'll hit enter. And it wants us to guess. So all we need to do is use our right and left cursor buttons, and then just get close. You just need to get close. And the intersection is at 2, 0. So we can write that down as one of our solutions. So we've got 2, 0, and we want to find this other one up here. So what I'm going to do is I'm going to go to zoom. Oops, let me go to zoom. And I'm going to go out, and then there's a cursor blinking right there. It doesn't really matter where you go, but I think we're going to zoom out just right in the middle. And then I think we'll be able to see that intersection. At least I hope. There it is right here. So if you want, you can zoom in on that spot. I'm going to do that. I'm going to go zoom and then hit 2. And then I'm going to move my cursor and this is going to be important when you zoom in, right over that position right there where you want to zoom in. So this will give us a little bit better view, and hopefully you can see this a little better there at home or wherever you are. And we've got that nice intersection right here, which is the one was off the screen before, but we think we know where it's at. So let's go to that calculate menu again, which is second trace. We're going to go down to number 5, or just hit 5. The first curve, it's actually on the line. You can cursor left and right if you're wondering which one it's on. It also tells you it's on y sub 1. So we'll hit enter. The second curve, now let's see here, I'm not really seeing it. Oh, there it is. See the cursor just came through there? You can look at the x if you're wondering where it went. And it's on the second curve, it's on the parabola, so we'll hit enter. We want to guess, and that's close enough. So the next intersection is negative 4.5 and 16.25. So kind of a neat thing that the calculator can do. It can find that intersection fairly precisely. In this case, it was just a decimal that ended, so it did a great job. It has trouble when there's something other than that, but you can get a good approximation using this method. So I guess those would go down here, kind of not writing it in the right spot, but you catch my drift, I hope. Alright, now we're going to do C and D, so these ones are even a little bit more interesting. And for C, I recognize that we have y is equal to 4 first, and that's going to be a line. So let me take a look at that. We'll get the old ruler out here, and we'll go to y is equal to 4, and just draw that straight line here. Now, this one's kind of tough to be able to use your graphing calculator, but we could subtract x squared from each side. So we'll have y squared equals 16 minus x squared, and then square root each side. So we'll have y is equal to plus or minus the square root of 16 minus x squared. My goodness. So let's try and graph each one of these on the graphing calculator. We have y is equal to 4. That's the first one to begin with here. And then, oops, let me clear all that, put a 4 in. And then the next one is y is equal to both positive and negative root 16 minus x squared. So we have to hit the second key, and then the square root key is this one down here. It's just second and then x squared. And then we're going to type 16 minus x squared right there. And then actually we're going to need to do the same thing again, but oops, we're just going to put a negative sign out in front there. Make sure it's a negative sign and not a minus sign. Kind of a little tricky thing here. When you start off, you got to start with this negative sign here. This minus sign is used when you're in the middle. So we'll just do the square root again, 16 minus x squared. Close it up, and this time we're going to want to hit zoom 6 so we can see a picture of what's happening here. Alright, there's the first part, there's the next part. And another thing you can do, this kind of looks like an oval, but if you want to square it up a little bit, you can hit zoom 5, and that'll really square things up for you, make the tick marks evenly spaced, so you can actually see that this is a circle and not just an oval looking deal. We think we have an intersection point, or maybe even a couple right up here. So what we're going to do is we're going to ask the calculator to calculate that out, and we're going to go to that intersection again. It's on the first curve, and it's actually a line that it's on, so you can hit enter. Jumps to the second curve, hit enter, and then you can go back and estimate where you think it intersects. And so this one's going to intersect at, now we have this crazy number here, and 4. This e to the negative 6 means take the value here, which is negative 2.542, and multiply it by 10 to the negative 6. Well, that would result in negative 0.00002542, which is very close to 0. And so the actual intersection point here is going to be 0, 4. And we'll write that down here. So it seems a little bit weird that the calculator writes that down. Why doesn't it just put 0? Well, the way it calculates the intersection is just off a touch. And based on your software, you might actually have a 0 there, and that's okay, or maybe even a different number, but either number is going to be super close to 0. And that appears to be the only intersection at that point. If we graph this, we can see this circle has a radius of 4 units, and it's centered at the origin. So we could come down here and put a point there, and put a point there, and we could just try to draw a nice little circle here. It's not going to be perfect, but just do the best job that you can. And that looks, well, fairly good. I suppose it could be a little more rounded there, come through in that direction, but, well, you can kind of tell what it looks like there. The next one, we've got a nice little symbol to deal with, so let's go to y equals. I'm going to clear out each one of these. And we're going to go to the absolute value. To get the absolute value, you have to go to Math, cursor right to number, and it's number 1. So you can just hit Enter. It's the absolute value of x, then plus 3, and then the next equation is negative 2x plus 3. So we have to type the negative key and then go negative 2x plus 3. And then we're going to go zoom 6 again, and it should be on the same viewing window. It's not squared up like it was before, but it should be pretty close. So we got this V shape, that's the first one, that's the absolute value. And it looks like it has a vertex here at 3. And each one of these lines is going to have a slope of 1. So there's the first part. Here's the next side. And this is a slope actually of negative 1 right here. And then negative 2x plus 3 would be right here. It's down to right 1, or up to left 1 for the slope. And we can see quite quickly here that we appear to have an intersection point right here at 0, 3. Let's ask the calculator to figure out if that is the case. So we'll go down to our intersection. The first curve is the absolute value 1, so it's the one that looks like a V. We'll hit Enter, jumps to the second curve, hit Enter, and then we'll guess here and just get close to that intersection point. And again, we have something very close to 0. This is 1.9 times 10 to the negative 14th power, which is 0.00000000000000019. Hope I had 13 zeros in there. And this is 3. So the solution is 0, 3 for this one.